Okay, this is chapter 10 on electrical circuits. I think basically, the overview here is, remember your formulas and you should be fine. Don't be shy to give a logical answer to something. One of the questions was, why does something not, why does the resistance not half when the potential difference across this halves? You can say simply it's, okay, it's not this linear relationship, therefore it's not ohmic. That's something you need to say, therefore it doesn't follow Ohm's law if it's not one like this. And then I thought, oh, it must be something to do with the temperature, because temperature is always going to affect the resistance, especially of something like a lamp, which it was. So just state those logical points, say whether or not something is ohmic, and that, that's correct. Circuit symbols, I think people often forget, I certainly did. This is this symbol for an LDR. I did not know that, so that could catch you off guard. I think I'll be able to work out what it is from that, but if they asked me to draw that in the exam, I don't think I would have been able to. The max power dissipation thing. I don't think it's outlined that. Please forgive me if I'm wrong, but I don't think it's outlined that much in OCR that it has to be covered. But it did come up in these questions, and I've seen it before in a question. It might have been an AQA question where they outlined the principle and then made you answer a question. So I think it's one of those like commonly, you don't know this, but here's a different example. It's that the maximum power is dissipated inside a cell where the internal resistance of the cell equals the total resistance of the circuit. Basically the reason is more mathematical if you just do the maths and see that that's where because obviously it's going to, if you change the resistance of the whole circuit, you change the current. But also if you just do the derivative of the of Kirchhoff's law equation, if you do the derivative of that to where the P by dr using I squared r for V, I think, and then EMF is I V plus V. EMF is I r plus r. You get that when it equals 0 is where little r equals big R. So I think apart from anything else, it's more just mathematical, but it's something that's good to be aware of because it seems like you could be asked it, and it's a good principle to be familiar with. In OCR, I guess they don't require you to do derivatives, but maybe they'd have some other way of solving it. Like in this question 7b, you have to fill in a table, and you can see that there's kind of a peak. They only had 3 values, which made it a bit more difficult, but you keep a lookout for that kind of things. Like if there's a peak, that's where the a peak in the power, that's where the maximum power is dissipated. And then you can say, oh, it seems as though from the trend shown that the maximum power is dissipated where the internal resistance of a cell is equal to the resistance of the circuit. Okay, I don't think there's anything else. We got this, let's keep going.